Africa is a land of mysteries and mind-blowing discoveries. From a hidden cave holding an unknown human species to a village where humans and crocodiles live in harmony, and deserts marked by strange, perfectly shaped fairy circles, the continent is full of secrets you won't see anywhere else. Join us as we explore the craziest things you can only see in Africa. In 2013, scientists faced an unusual problem. They needed researchers small enough to squeeze through cave passages barely wider than a mailbox. What they found inside changed everything. A previously unknown human species with brains a third the size of ours, yet capable of complex burial rituals. The discovery was made deep within a remote chamber of the Rising Star cave system in South Africa. The fossils include 737 individual elements, ranging from skulls and jaws to ribs, teeth, limbs, and inner ear bones. They represent old adults, young adults, and infants of both sexes. Some remains were articulated or nearly complete, including a skull with its jaw and almost intact hands and feet. This makes the collection the richest set of associated hominin fossils ever found in Africa, rivaled only by the Cima de los Soso site and later Neanderthal and modern human discoveries. Excavating the chamber was an extraordinary challenge. Narrow passages and jagged rock formations made it nearly impossible for most adult researchers to reach the fossils. To access the site, a team of small-bodied women was recruited specifically for their ability to navigate the tight spaces and recover the remains safely. The bones reveal a striking mix of primitive and advanced traits. The hands and feet suggest the species could manipulate objects with precision, while its small brain, about one-third the size of a modern human's, challenged long-held assumptions about intelligence. Despite this, the evidence points to complex behavior and social organization, unlike anything expected from such a small-brained hominin. Radiometric dating places Homo naledi between 236 and 335,000 years ago, though the exact timeline remains uncertain. This timeline means Homo naledi lived alongside Homo sapiens in Africa, two different human species coexisting, possibly even encountering each other. One of the greatest mysteries remains how so many individuals ended up deep inside the cave. Some scientists suggest deliberate body placement, while others propose a deadly trap. Whatever the explanation, parts of the story may never be fully known.
Children play in water while crocodiles swim past them. Villagers walk between animals that could kill with one bite. In Banjul, Burkina Faso, what should be deadly is daily life. Humans and crocodiles have coexisted peacefully for centuries. Here, crocodiles do not hunt humans, and villagers go about their routines as if nothing is unusual. Researchers who have visited the village to study the animals have been struck by their calm behavior. The crocodiles move through the water without aggression, even when children are nearby. The key to this peaceful coexistence lies in years of careful conditioning. Villagers feed the crocodiles regularly, offering fish, chicken, and other favored foods. Because reptiles can go months without eating, this consistent feeding reduces their need to hunt. Over time, the animals have learned that humans are not a threat and that interaction brings food rather than danger. Residents also view the crocodiles as sacred. They believe the animals protect the village and embody ancestral spirits. According to local tradition, this bond dates back to the 15th century when crocodiles are said to have guided the community through a devastating drought. Since then, trust has been passed down through generations, and children swim in the same waters without fear. This relationship is celebrated through Kumlakura, a local festival that honors the sacred crocodiles. During the ceremony, villagers offer prayers and gifts, asking for health, prosperity, and the continued protection of both the people and the animals. For more than 50 years, ecologists have studied and debated a strange pattern spread across the Namib Desert, where near-perfect circles interrupt the grasslands of southern Africa. Known as fairy circles, these formations stretch across roughly 1,100 meters of dry terrain and appear as round patches where grass is thin or completely absent. Their size, scale, and consistency make them one of the most unusual natural patterns ever documented on the African continent. Over time, scientists proposed many explanations for how these circles form. One theory claimed termites were destroying grass roots from below, while another suggested the pattern emerged from how desert grasses evolved to survive extreme dryness. For decades, evidence supported parts of both ideas, but neither fully explained what was happening. A recent study led by Stefan Getzen, an ecologist at the University of Göttingen in Germany, now sheds light on a mystery that has puzzled African ecology for generations. The research shows that fairy circles are defined not just by their empty centers, but by the thick, healthy grasses forming a sharp ring around each one. Data collected across multiple rainfall seasons revealed a consistent and unexpected pattern. Water inside the circles drained rapidly, even though no grass was present to use it, while the grasses along the edges remained strong and well supplied. The answer is surprisingly competitive. Grasses at the circle's edge pull moisture from the center toward themselves, creating a dead zone inside. Any grass trying to grow in the center is starved of water and dies, while the outer ring thrives. The bare center becomes a water reservoir that feeds only the plants surrounding it. To track this process, researchers installed 12 soil moisture sensors at regular intervals between two fairy circles, all placed at the same depth. The sensors continuously recorded water movement through the soil, confirming that moisture consistently flowed from the center toward the outer ring. The circular shape itself is a key part of this system. A round formation allows each plant along the boundary to access shared water efficiently while limiting competition. Any other shape would spread the same plants over a longer boundary, reducing the amount of water available to each one. In simple geometric terms, the circle is the most efficient shape for survival in an environment with scarce water. Although this system prevents growth in the center, it significantly improves the survival chances of the grasses along the edges. Similar self-organized patterns exist in other dry regions of the world, but the scale and clarity of this process in the African desert make it especially striking.
Lower your hand into the Ruki River and it vanishes, not in deep water, but inches below the surface. This is the darkest river on Earth, so black that light dies before penetrating even a few inches. At its mouth, the Ruki is about half a kilometer wide and carries an average flow far greater than that of the Rhine. Yet it remains largely unknown outside Africa. For the people who live along its banks, the river's color is a normal part of daily life. For researchers from ET Zurich, however, its extreme darkness raised questions that would later reveal its global importance. The Ruki is classified as a blackwater river, meaning its color comes from dissolved organic compounds rather than mud or sediment. The river flows through mostly flat land, so it does not erode much soil. While sediments can darken clear streams, it rarely produces the deep black color created by organic material from tropical forests. Heavy rainfall plays a central role in this process. Rain washes dissolved compounds from fallen leaves and plant matter on the forest floor into the river. During the rainy season, large areas flood and remain underwater for weeks, allowing even more organic material to leach into the water and intensify the river's dark appearance. Many rivers pass through tropical rainforests and flat landscapes, including several within the Congo Basin, yet none are as dark as the Ruki. Because this difference had never been adequately explained, researchers set up a monitoring station just upstream of where the Ruki meets the Congo to study its water chemistry in detail. The team measured the concentrations and ages of dissolved organic compounds to determine whether they originated in peat bogs along the river banks.
These bogs contain vast amounts of undecomposed plant matter and act as major carbon stores. If large quantities of this carbon were to escape into the atmosphere, it could significantly worsen global warming. The analysis showed that very little carbon from the peat bogs is being released. Even so, the Rukki carries unusually high levels of organic material. It contains 4 times as many dissolved organic compounds per liter as the Congo at their junction, and 1.5 times as many as the Rio Negro, explaining why water visibility is almost non-existent. This gives the Rukki a disproportionate influence on the global carbon cycle. Although its waters contain organic acids capable of releasing carbon dioxide, the river's slow, calm flow limits how much gas escapes once the water becomes saturated, preventing a larger release into the atmosphere. This balance remains fragile. Increased farming, lower dry season water levels, longer exposure to peat bogs to air, or more turbulent flows during heavy rains could all disrupt the system and alter how carbon moves through the river. Across the Congo Basin, environmental changes pose serious global risks, and this research shows that the Rukki is especially significant. Despite making up only 5% of the basin by area and 9% by water flow, the river accounts for roughly 1/5 of the dissolved organic compounds carried through the system.